r. So I can see from here that the coefficient of x to the power of r is simply 1/4 to the power of r plus 1. Okay? Okay, I hope it makes sense to you. Okay, now okay, if you are ready, we will move on to the next example. If you want to, you may use the same method to try part B. Okay, you can pause this video and try part B on your own if you would like to. Okay, once you are ready to go on to part B, you can start the video again. Okay, now we go on to 8 part B. Okay, this is the expansion. We want the general term in x to the power of r. So again, recall the formula is n times n minus 1 all the way to n minus r plus 1 over r factorial. Okay, so our n is minus 3. So n minus 1 will be minus 4 all the way to n minus r plus 1 over r factorial times x to the power of r. In this case, your x is 2x. So 2x to the power of r. Okay, again, we want to simplify this expression. So you can see that minus 3 minus r plus 1 will just give me minus 2 minus r. So I will have minus 3 minus 4 times all the way to minus 2 minus r over r factorial. So again here, right, I can break it up to 2 to the power of r and x to the power of r. So similarly, okay, just as in part 8 part A, I take out all the minus 1s from here, right? So minus 3, I can write it as minus 1 times 3. Minus 4, I can write it as minus 1 times 4. And minus 2, I can write it as minus 1 times r plus 2. Okay, so in total, there are r times of minus 1. So I write it as minus 1 to the power of r, okay, times, okay, now I take out the minus, right? So I'll be left with 3 times 4 times 5 all the way to r plus 2 over r factorial, okay, 2 to the power of r, x to the power of r. Okay, after this, okay, I need to simplify this part. I can see that, okay, 3 times 4, okay, I can try to write more terms so that you can see what I'm trying to do. So same thing, I'll be left with minus 1 to the power of r. And then the numerator, right, I can write it as 3 times 4 all the way to r times r plus 1 times r plus 2. Okay, and 2 to the power r and x to the power remains. The denominator, I can write it as r factorial, right? So r factorial can be written as 1 times 2 times 3 times 4 all the way to r. So I can see that I can cancel off the terms, right? Like 3 can cancel with 3, 4 can cancel with 4, and all the terms in between will be cancelled also all the way to r. I can cancel all the way until r. So for the numerator, I will be left with r plus 1 and r plus 2, right? Because 3, 4, 5 all the way to r will be cancelled off. Okay, until I'm left with r plus 1 and r plus 2. And the denominator, because we start cancelling from 3, so denominator I'll be left with 2. Okay, and then we continue to write 2r plus 2 to the power of r, x to the power of r. So from here, okay, you can see that this is also 2, right? This is 2 to the power minus 1. So I can write it as minus 1 to the power of r remains, and then this is 2, base 2 and base 2, so this is 2 to the power of r minus 1. Continue writing the numerator r plus 1, r plus 2, and x to the power of r. So from here we cannot simplify further, so we can say that the coefficient of x to the power of r is equals to minus, you can see that from here the coefficient of x to the power of r is minus 1 to the power of r times 2 to the power of r minus 1 times r plus 1 times r plus 2. Okay, that's all for binomial expansion. Okay, if you have any questions, feel free to email me at, this is my email address. Okay, if not, we'll see you next week in the LT. Okay, thank you.